Hello and welcome. This is a brief introduction to climate change, where we talk a little bit about how these shifts could actually alter the climate across the globe and have an impact on humanity into the future. Now, we're just going to be covering key concepts here, and that's to give us the opportunity to begin envisioning and thinking about what our opportunities are to potentially shift the direction of things going into the future. So this is Earth. This is the most famous photograph of Earth in existence. Most of them that are used are this picture. It's called the Blue Marble. And it's taken by NASA of the Earth when you could just see the entire Earth. It was lit from behind by the sun. Now, everybody you've ever known, everybody throughout history was born and has lived their lives on Earth. It's really quite amazing when you think about it. I like showing it in part because it's beautiful. It's just a reminder that there is a finite border to the world that we live on. It is a space where there's a limited atmosphere, limited resources, and we have the great fortune to be able to live on this rich planet. One thing when we're talking about climate and the atmosphere is that this atmosphere is actually really fairly slender. This is a picture of the atmosphere, the toposphere, from the side. And it's actually this very thin shell covering the Earth. We often think about the sky as being limitless, but really the toposphere is only about 5 to 10 miles thick, right? So if you think about it in another way, if you imagine like a schoolroom globe, if you coated that schoolroom globe with just a coat of shellac, that would be about the thickness of the atmosphere. Now, despite the fact that this is we think about the atmosphere as being limitless, when we pump massive amounts of greenhouse gases into it, we can actually start filling it up. We've put about 110 million tons of carbon dioxide into the air every single day. Greenhouse gases, generally speaking. And that, over time, will have a substantial impact. Since the beginning of the industrial era, our carbon dioxide levels in the atmosphere have increased by about 40%. So what does this look like? Why is this happening? Well, there's a bunch of different sources. Transportation is a major source of greenhouse gases. The way that we generate electricity, which we use, different types of industrial processes, the way that we use land and our agricultural practices and approaches, and the food that we eat, different commercial elements and residential practices as well, have a significant impact on these emissions, as well as other things like methane released from melting permafrost and land use and deforestation and all these different things contribute to these climate gases that are building up in our atmosphere. Now, this has been a big shift. If you look across history, which is the top graph here, you'll see that the highest historical levels of CO2 were about 300 parts per million in the past 400,000 years. Now, in 1950s, we were around 300 parts per million, but we've had a rapid spike that has gone to historically incredibly high levels of CO2 in the atmosphere. I think today we're at around 417 parts per million currently. So we can look at this recent progression, and we see over the last decade or so that there's been this steady rise in CO2, and it's happening actually really quite fast. Now, what is the greenhouse effect? Why do we care about these greenhouse gases? Well, it's normal that when the sun emits energy that hits the Earth, some of the light that hits the Earth is going to be reflected back into space. And that's energy that just escapes, that doesn't get captured on Earth. Other elements to that energy just stay on the Earth. They're captured when they hit the Earth. But there's also some energy that gets reflected back towards the Earth by the atmosphere. So it doesn't actually escape, and it gets trapped in the atmosphere. And this is called the greenhouse effect, right? Where an increase in these greenhouse gases are essentially retaining this energy from the sun around the surface of the globe. So this trapped energy is increasing, and it's really quite substantial. To give a more visual depiction of what this trapped energy looks like, this man-made global pollution is now producing additional energy on the Earth of about the equivalent of 400,000 Hiroshima atomic bombs being exploded every single day, all 365 days of the year. So that gives you an idea of the excess heat that's gathering in our atmosphere due to the release of greenhouse gases. Now, when you think about what this looks like in terms of the changing temperatures over the last century or so, this is another depiction that I find useful. At the very top, it's kind of small, but at the very top, you'll see the scale of what 1 degree Celsius looks like. And you see that it's colder at the beginning of the century. And as you go throughout the century down to the lower part of this diagram, you'll see that it's getting hotter and hotter. Instead of being below the line, we're seeing that regularly we're seeing spikes in terms of getting some of the hottest years on record, particularly in the last 10 years or so. So here's another thing that you can look at to see this. This is another type of chart where you see the rise in temperature over the last few decades. And you also see that associated with the CO2 concentration increasing as well. And we know that correlation isn't necessarily causation, but there's a lot of other evidence that shows that these greenhouse gases is actually a causal factor in this increase in temperature that I can discuss at a later point. So the international organization, IPCC, that's looking at these types of questions has shown, using a range of different evidence, that it would be to a tremendous advantage for us to keep this warming of the Earth below 1.5 degrees Celsius. Now, what we're seeing, however, is that there's a certain amount of greenhouse gases that we can emit. Essentially, there's a budget. It goes into the atmosphere and it doesn't get removed from the atmosphere very fast. So we're using that budget of releasing a lot of greenhouse gases very fast. We actually only have about 9% of that budget left, or about 10 years worth of emissions at our current rates, before we get above that 1.5 degree threshold. And so you've heard 2030 as being a cutoff for a lot of changes in climate change. And that's what that essentially means, is we're going to have used up the budget of greenhouse gases that we can release into the atmosphere before we're pretty hardwired into reaching that 1.5 degrees Celsius cutoff point, after which we can expect more severe impacts on ecosystems as we currently know them. Now, there's another element to this in addition to just general increases in temperature. This is that the summer temperatures, and these are charts of summer temperatures, have actually shifted. So this is a picture of the average sort of bell curve of temperatures from 1951 to 1980. And you'll see that below the mean, which is the mean being 0, you have temperatures that are cooler than average, and then you see the data for years that are above average, warmer than average, marked in red. Now, we see that this starts to shift. If you look at that bell curve, the green bell curve sort of representing that 1951 to 1980 data, when we look at 1983 to 1993, we see that that curve has shifted upwards. Again, the green is showing our baseline, all right? Now, what you're seeing start to appear at the upper end of that red component is what we call extremely hot weather. And this is weather that is actually dangerous. These are sort of outside of the norm, above the third deviation from the mean, right? Third percentile. So we're starting to see more of these extreme weather. You will also see extreme weather at the lower end as well. Now, when we look at 1994 to 2004, we see even more of these extreme days, extreme weather that we're experiencing throughout the years. As we go to 2005 to 2015, we see, again, even more of these extreme weather as compared to that baseline. You'll also notice that this bell curve is getting shorter, right? So what that means is that we're having more extreme weather on either side. It's just extending out so that we're having more erratic weather. So there's, some people call this climate chaos in some ways because we have more of the extremes in either direction. It used to be that these extreme events were only about 1% of the Earth, and now they cover about 14.5%, right? So where does this heat that's gathering go? Well, about 93% of the excess heat that we're gathering in the atmosphere, and is trapped by these man-made gases, goes into the ocean. The ocean is an incredible sink for heat. Because water can just absorb a lot of energy. So our oceans are actually increasing in temperature. We're very fortunate that it's doing so because otherwise the landmass would be heating up much faster than it currently is. So what does this mean? When you have increased temperature in the atmosphere and increased temperature in the water, you will start to see increased water in the air, right? So every additional 1 degree Celsius of temperature in the atmosphere, it has the capacity to hold about 7% more water vapor. The warmer the air is, the more water vapor it can hold. So currently, we have about 4% more water in the vapor in the air than we saw about 30 years ago. So what does this mean? Well, this means that the buildup of water in the air is going to dramatically impact our climate. Not only the increased temperature, but also the increase in water. So when we see these floods or storms that are really severe and serious, and people say, well, was this actually caused by climate change or not? Was this extreme weather event caused by climate change? Well, in some senses, it's hard to, for natural phenomena, which are tremendously complex, it's hard to nail down exactly the origins of specific, weather patterns. But in the sense that we have 4% more water in the air at all times, in some senses, all major weather events are caused by climate change because that 4% makes a difference in terms of how these storms the trajectory that they carry out. So in some senses, the answer to this question, was it caused by climate change? Well, in some ways, climate change contributes to essentially all climate events at this point. So when we think about what we're going to do about these challenges that we just talked about, well, we have actually a lot of opportunities, and there's reasons to have hope, right? So we have increasing greenhouse gas concentrations. We've seen that, which leads to climate change and resulting impacts. Now, there are things that we can do in response to this. One thing that we can do is mitigation, and that means, as you see the arrow going back up to greenhouse gas concentrations, we can do a range of different things to decrease the amount of greenhouse gases that we're producing. And we call this mitigation. And that's one side of our response to climate change. The other side is adaptation. And adaptation is the different things that we do to deal with the impacts of climate change. So given that even if we do mitigate climate change, it's still going to occur, we still have to do a range of different things to effectively adapt to the changes that we are going to expect over the coming century. And that involves a lot of planning, strategies, and investment of energy, time, and resources to actually be prepared for those situations. Now, I think it's important from the very get-go to highlight that the impact of climate change is not going to be equitable. All right. When we look at globally where the climate change greenhouse gases are coming from, you can look at the chart at the top, and you'll see that the vast majority of climate greenhouse gases are from the global north, industrialized countries in particular. However, when you look at the different types of impacts of climate change, things like actual mortality from climate change related events like different types of infectious diseases, drought, starvation, heat exhaustion, etc. What we find from the data is that the vast majority of these climate impacts are occurring in the global south. And it's not just an international issue here in terms of inequity in that sense. It's also the fact that pretty much every serious climate change event affects people who are disadvantaged more severely. So this is something that we need to think about from the very get-go as we're thinking about adaptation strategies and mitigation as well in some senses. So what is the impact of climate change on human health? Well, there's a lot of them. There's such changes in climate, showed in the center of this graph, where we see things like rising sea levels, increased CO2 levels, rising temperatures, and more extreme weather. And these have impacts, right? So I won't list all of them. You can read them, but things like air pollution, increasing in asthma as a result, and cardiovascular disease due to the increase in ozone that's trapped. We can have impacts on water quality and harmful algae blooms, for example. We can have extreme heat, which has very severe impacts on health, particularly for the elderly and other vulnerable populations. We can have societal disruptions of various sorts. For example, migration and mental health impacts. And there's just a wide range of different things. And there's many climate change impacts that affect health that aren't even listed here. So if we're thinking about public health and public health impacts, we have to take climate change very seriously as we're planned for the coming century. This is going to affect pretty much all areas of public health going into the future, and the clinical work as well. So in summary, this is kind of a general overview of where we're at with climate change. This is something that is very serious, that it's being talked about at societal level. There's a lot of conversation about how we should address this, and a lot of controversy about it. And I look forward to talking more about that and thinking more about that with you. But I also want to emphasize that there is hope here. There are things that we can do to address this, and it really requires learning more, thinking more about this, and really starting to take action to address these different types of challenges as we go into the future to protect both our environment, this beautiful blue globe that we live on, and also the health of our families and the people to come and the ecosystems that we live in. So just some thoughts for you. Take care and be well.